Hey there. In this video, we are going to be asking the question, are the two quantities proportional? What do I mean by are the two quantities proportional? Another way to think about it is, do the two quantities have a constant ratio? Constant ratio. Remember, constant means unchanging. So a constant ratio. A ratio looks a lot like a fraction oftentimes. There's different ways to write it. We can also say it this way. Can the ratios be simplified to the same amount? And when you simplify a ratio to the same amount, you're looking at equivalent fractions. So are the two quantities proportional? The goals we're going to have as part of this little video is how to show if two quantities are proportional. So what can we do to show if a relationship between two quantities is proportional or not proportional? Let's look at an example. A seaweed plant grew 9 feet every 4 days. Is the length the seaweed grew proportional to the number of days? Let's slow down here and pay close attention to the language. We'll write that. Note the language, because that's going to help us. Note the language. So the question reads, is the length of the seaweed grew proportional to the number of days? So is the length proportional to the number of days? So length I can measure, days I can measure. And this language is a lot like something you've seen before when we did ratios. So let's do a little detour here. Remember, if I say 3 dogs to 2 cats, and you're asked, well, how would I write this as a fraction, the way this ratio is written? Well, I would write 3 to 2, right? Because what comes before the 2 is tell me what's on top. What comes after 2 comes in the bottom. And so here I have this language. So that means when I go to set this up, I want to check the ratio. So in this case, they gave me a table that's not complete. Okay, so if it grew in 4 days, it grew 9 feet. Let's fill this in. Let's see, in 8 days, that's twice 4, so it would have grown 18 feet. And in 4 more days, it would have grown another 9 feet, and that would make it to 27. And then another 4 days, another 9 feet is 36. So we can see how this is going up by 4 each time. And in this case, this is going up by 4. So in order to determine it's proportional, what we have to do is we have to check the ratio of each ratio in the relationship that we have. And we're going to pay attention to this language here. So we're going to do the length to the number of days, because that's what I'm being asked. Is the length proportional number of days? So I want to set up a ratio that's length to days. And I need to check each of these ratios. So the first length is 9 to 4. So I ask myself, what does 9 over 4 simplify to? Well, this one's going to be a little clumsy here because I'm going to have to do a little bit of division. So I've got 9 divided by 4, and I can get 2 out of that. That equals 2 times 4 is 8. I have 1. So this one's going to be 2 and 1/4 is what it simplifies to. Let's check the next one. This is going to be 18 over 8. And I'm looking, does this simplify to the same thing that this simplifies to? So I'm going to have 8 and 18. Well, I can get 2 8s out of 18. 8 times 2 is 16. 18 minus 16 is 2. So I'm left with 2 and 2 8s, right? 2 and 2 8s. And 2 8s simplifies to 2 and 1/4. So these are the same. My next ratio I have to check is 27 over 12, because that's the length to the number of days. So if I go 27 and a 12, or 12 divided by 27. I said that wrong, didn't I? 27 divided by 12. How many 12s can I get out of 27? Well, I get 2. 2 times 12 is 24. And I have 27 minus 24 is 3. So I have 2 and 3 twelfths. And 3 twelfths also simplifies to 2 and a fourth. Right? 3 twelfths, same as 2 and a fourth. And I have one more to check here. 36 over 16. You might be asking, do I have to check every ratio? If it's going to be proportional, yes, everyone has to be checked. So now I have, so I'm going to do it right here. So I'm going to have 36 divided by 16. How many 16s going to have 36? I can get 2. 2 times 16 is 32. 36 minus 32 is 4. So I have 2 and 4 sixteenths. And 4 sixteenths also simplifies to 2 and 1/4. So each ratio simplified to 2 and a quarter. And that means it has the ratio is constant. They can all be simplified to 2 and 1/4. And we can also double check. 2 and 1/4, if I was to turn this into an improper fraction, 4 times 2 is 8, plus 1 is 9. 9/4. So they all simplify to the same thing. So yes, the length of seaweed, that's seawood, the seaweed grew is proportional to the number of days. So in this case, each one of the ratios simplified the same thing. That means this relationship is proportional. Let's look at another example. The number of hours Alfred works and the amount he earns is shown below. Is the amount of money Alfred makes proportional to the number of hours he works? Notice the language again. You've got, is the amount of money Alfred makes proportional to the hours he works? So if it's proportional, what we have to do is we have to set up the ratio. So in this case, it's money, and money's measured in dollars. So we have dollars to hours. So dollars, money, to hours. And the first one, we're going to check, so we need to check 26 over 2. Well, 26 over 2 is 26 divided by 2, or 13. 65 over 5. 65 over 5. I'm going to enlist the help of a calculator right now just to speed the video along. Hello there. So if I go 65 divided by 5, 65 divided by 5, that's going to equal 13. So far, so good. Let's check this. $117 divided by 9 hours. And that's, again, 13. So 117, the ratio. It's also 13. And the last one, 130 divided by 10. Oh, hey, I recognize that because I can just cancel those two zeros off. I've got 13 over 1. It's 13. So they're all the same. As a matter of fact, we should notice, and this is our big hint, all of these are 13 over 1. So that's $13 in 1 hour. Hey, that's an example of a unit rate. So this constant ratio that we're showing is a unit rate because it's out of 1. So it simplifies, each ratio simplifies the same amount. So yes, the number of dollars, so the dollars earned is proportional to the hours worked. It's good to be clear how we're doing this because pretty soon we're going to do this another way. We also remember this right here, just so we get the language, it's a unit rate. It's got one. It's the same unit rate. So that means this right here is my constant ratio. Matter of fact, this is a vocabulary term, a constant ratio. I'm going to highlight this in green to point out this is a vocabulary term. It's a real important idea. It's an unchanging ratio. It's a constant ratio. One more and then we're going to be done. The cost to enter the fare is $5. Tickets for rides cost $1 each, period. Is the total cost proportional to the number of tickets purchased? So if I bought one ticket, what would the total cost? It would be $1 for the ticket, but the total cost includes getting in the fare. So $1 for the ticket plus $5 again, that would total cost would be $6. If I bought 5 tickets, it'd be $5 for the tickets, $1 each, plus $5 to get in. So it'd be 5 plus 5, that would be $10. Let me write this in here. So 1 for the ticket plus 5 to get in. If I bought 10 tickets, there'd be $10 for the tickets plus 5 again, that would be 15. If I bought 20 tickets, it'd be 20 for the tickets plus 5 to get in, or 25. So paying attention again to the language. Total cost to number of tickets. Right? Total cost to number of tickets. So total cost to the number of tickets. TIX, can I abbreviate that way? The first thing I want to check, the total cost is 6 to 1. Well, that's simple enough. That's 6. The next one we have is 10 to 5. Well, 10 to 5 actually simplifies to 2. And these two are not equal. And because they're not equal, we know immediately that this relationship is not proportional. I don't even have to bother checking these others, but I could. 15 over 10 is going to simplify to, I can divide each of these by 5. And then I get 3 halves. Well, clearly that's not 2. And this one here, I did 25 over 20. Again, I divide by 5, top and bottom, and I would have 5 over 4. It only takes one not to be the same. You could have 5 of them that are the same and one that's different. The relationship isn't proportional. In this case, they all have to be different. So the relationship between total cost, remember, total cost, and number of tickets is not proportional. Number of tickets is not proportional. And it's not proportional because no constant ratio. Let's point that out. No constant ratio. I realize this video is getting a little long. While going through the details, of course, you can stop and go back. So remember our goal that we started off with. Our goal was how to show if two quantities are proportional. So two quantities, like hours worked and money earned, is proportional if you can simplify all the ratios and you have a constant ratio. So in this case it works. These all simplified to the same thing, 2 1/4. So this was a constant ratio. This relationship is proportional. And this last one here with the total cost and the number of tickets, this is not proportional because the ratio of these things did not simplify to the same thing. Well, hope that helps. It's a little long, but this is an important idea, and we're going to pick this up and continue with this visually with graphs in the very near future. Bye for now.